My name is Simon Margolis. I direct the cloud platform practice at SADA Systems. And SADA's had the pleasure of working with our panelists to help them with their cloud journey. And so I want to go through the panel here, just give a quick introduction, ask everyone to maybe introduce yourself and talk a little bit about what you do. So without further ado, Anastasia Mishlov with Reltio, please.
Thank you, Simon. My name is Anastasia, and over 7 years ago, I co-founded a company which name is Reltio. And our goal was to build a product that allows to organize all of the enterprise data in one single place. So let me give you an example. Let's say I'm working in a wealth management company, and there are not that many opportunities, and finding new clients is extremely hard. So let's say in my system, I have a person whose name is Scott. And he's a software engineer, and most likely I'll be not targeting this person. But from other sources from the enterprise, I realized that there are more details about Scott. Scott is working in company XYZ. And recently in the news, we learned that it has a very successful round of funding. And based on all statistics through the enterprise, we know that this kind of companies are going IPO. And there are more details. Scott is actually was the first developer in this company. So now you see that all this context is giving completely different flavor to Scott. And now, as a person working in wealth management company, I need to reach out to this person as fast as possible, because 2 years from now, it will be already too late. But the problem is that in enterprise, there's no single place where I could get all of this information together. That's why at Reltio, our mission was to build a place where I can have reliable data from all over enterprise that I can transform into relevant insights, and also want to have recommendation frameworks. So me, instead of scanning through millions of profiles of Scots, I can have just an alert in the system, hey, Stacia, you need to work with this person. And if you think about enterprise, it was an example about wealth management, but in every enterprise, there are the same kind of problems. You want to leverage all the information about individuals, organizations, products to drive your business.
Thank you, Stacia. So then next, Aaron Brown with MadHive. If you could tell us a little bit about yourself.
Yeah, hi, my name is Aaron. I work at MadHive. I'm the VP of Engineering. MadHive is a New York-based ad tech firm. For those who don't know, ad tech is sort of the science and infrastructure behind advertising. And that comes with a lot of engineering kind of challenges. We deal with very, very large scale. They're real-time exchanges for ads. You know, advertisers don't know where you're going to go on the internet next, and you just sort of appear. And we have to make sure that the right advertisement gets there. And there are a whole lot more ads on the internet than just about anything else, so it gets big. And the data science is also very important. You know, if we show you the wrong ad, then you're just going to pass off, and that's, you know, money lost. The other thing we work on very heavily is privacy, and that's almost sort of contradictory in that industry, but privacy is very, very important. We believe privacy is a human right, first and foremost, and advertising is kind of creepy in that regard, sort of follow you around everywhere. You looked at that bicycle on Amazon one time, and it's just like everywhere you go. That's sort of weird, and you know, even in innocent cases, a little creepy, and the nefarious cases are very creepy. So we like to stop that. And also, advertising has problems because of that huge scale and because of all those very, very low latency requirements. There are tons and tons of companies involved in the advertising supply chain, like maybe sometimes 20 companies just to show you one ad. And when you have 20 companies sort of working on data in an industry where data is your value, so you want to work together and check notes, but you don't want to show each other anything, what happens is there are very, very large discrepancies, sometimes of the order of 10%, which is not great because ads are kind of like digital money. We're like the original digital currency. You know, each one of those little ads is some money. And when you're being fast and loose with people's money, you know, it's a big problem. So we try to solve all these things at once with privacy. So privacy is about sort of securing data to make sure that is not tampered with, always in your control. And this works really, really well for us consumers, and also works really, really well for us in the ad tech business, because now when data has sort of provenance and sort of control, the stuff like doing accounting, auditing gets really, really easy.
Awesome. Thank you, Aaron. So Josh Gray, Principal Architect with Citrix. If you could tell us a little bit about yourself.
All right. Thanks, Simon. I actually just joined Citrix a few months ago when they acquired my last company called Sodexis. And what we did at Sodexis is, for about the last 9 years, we built the largest community of global internet performance data in the world. And we started about 2009 and grew it to a place where we see about 1 billion users every day. We collect tens of billions of data points, and we aggregate that all to give insight into what's really going on in the internet. So we effectively measure every major public provider of infrastructure, many private providers of infrastructure. We watch whether there's congestion, how the throughput is behaving, what the round trip times look like. We roll all that data through a very rich analytics and reporting infrastructure, and then we also do very active, very low latency global traffic management based on that. So there's a lot of very high scale, very high speed, very low latency use cases that we deal with. The nature of the business that we're in is that we are actually consumers of virtually all of these providers that we monitor. And so, we keep an eye on them, but we also run a 24/7, 365 global service on top of them. And Google has been our fastest growing vendor that we use as it's continued to capture use cases in our own infrastructure. We continue to be multi-cloud, multi-vendor, and that will likely continue. But on the merits of what we see with the use cases that we capture, it's been a really exciting journey to keep moving things forward.
Awesome, thank you, Josh. And then last, we'll go to Glenn Pringle, Innovation Lead at Monash University.
Thanks, Simon. So Monash University is the largest university in Australia. So although we're only 60 years old, we've got presence across 4 continents, and we have, we're number 1 university for engineering and technology in Australia as well. Being such a large university, we've got a really diverse set of needs. So we have numerous researchers. We're a research-intensive university, and they have enormous different needs. We have educators. We have a very large number of students, and we've actually found that we are using cloud more and more so that they can meet a lot of those diverse needs. So as an innovation lead, I'm working with those people and looking to really help them to make use of cloud, and in particular Google Cloud, to achieve that.
Awesome. Thank you, Glenn. And I'll actually start with you, since you're holding the microphone. So, I wanted to ask you a little bit about what really drove you to start adopting the cloud, and then if you could talk a little bit about why Google Cloud in particular stood out to you.
Yeah, sure. So we didn't actually approach cloud looking to reduce cost. So we're looking for a number of things. So we're really looking for flexibility. So as we're trying to achieve those things I mentioned earlier, we're wanting solutions where we can quickly and easily be able to use the resources and looking for a real range of different resources to do a lot of different things. Speed of delivery is a really big thing too. So previously, if we were working with infrastructure, it took a lot of time to prepare, to get that infrastructure ready, to bring it into production. Whereas when we're going with cloud, it's available when we need it. And it's not just being able to bring it in instantly, it's also about being able to use that really wide range of different resources and bring them in as we need them. And scalability. As I already mentioned, being able to ramp up with infrastructure. When we used to run into problems, we would have to go and order new hardware. So if we want to scale up, there'll be up to months' time before that became available. Whereas once we're in the cloud, we now see that using auto-scaling, that hardware, that compute is available before we even know that we need it. So As we look at the issues around people, process, and technology, we've actually found that using cloud takes technology out of that. It becomes the simplest part of those three. And we're no longer really struggling to deal with that technology side like we used to be.
That's awesome. That's great to know. So actually, my next question right next to you is for Josh.
We didn't plan this early.
This is only starting well. We'll have to play hot microphone in a little bit. So you mentioned you've worked in a few different cloud providers. You work in a few different environments overall. What challenges were you looking to solve that kind of led you towards looking for some alternatives to what you already had in your wheelhouse and eventually to Google?
Yeah. So our early use case that kind of brought us to Google Cloud is we have really large data sets, tens of billions of rows with hundreds of columns and attributes that are collected constantly, and we have a lot of really low latency cases to get insight. Our data gets a lot less interesting the more time passes, and so as days, weeks, hours go by, if that's how long it takes to get results, sometimes that's not meaningful anymore. So our main use case was to extract more valuable information out of our data sets and make it more accessible to our teams. And so we ended up looking through a lot of different data architectures and have tried virtually everything that exists and got really attracted to BigQuery early on and pushed it hard. We had many millions of tables of data, did some good work with the BQ team on refining our approaches so that it aligned with their expectations, and ended up getting some really amazing results. And to me, there's a lot of solutions out there. There's a lot of options for data and analytics and that kind of approach. But what really made the difference is it was truly a managed service. You just kind of dump data into it, and then you have SQL access to it, and you don't have to think about things like instance sizing or there's truly a managed layer to it that just works. And the fact that I could do multi-terabyte inquiries with SQL, which vast majority of my team was already familiar with, really made it so that people started pulling out value a lot more easily. There was no training, no specialized familiarity of a new framework or a new programming model that had to be done. So, that got us kind of into the BigQuery, and it has been a large part of our infrastructure for several years now, and we continue to grow and push that. And then we've actually been layering in other use cases. We do a lot of things just with instances and global management. We do a lot of edge computing, and the quality of engineering result. Again, we're in the business of watching all these cloud providers and all these CDNs and all these data centers. So we get a tremendous amount of data, not just through our own collection, but also with our customers who help us collect this data. And just on the merits of a lot of these, like the engineering of the edge platform between the clouds is just really impressive work. A lot of the capabilities for very rapid changing of virtualized resources. Again, really good results. And as a result, we've had increasing tiers through our stack that have gotten picked up with solutions that are running on Google Cloud. So.
Yeah, that's great. So it sounds like there were some unique things to GCP that kind of allowed you to do things you otherwise would have, I guess, had a lot of pain around.
Yeah, it was absolutely true. There's one other dimension too, is a lot of the offerings, they were externalizations of very mature technology. Like, BigQuery is based on the Dremel paper, which is 10-ish years old. So not only had there been a lot of good thinking, good work, but it had, the solution had a lot of miles on it with their own internal usage. And we've found that frequently that even the newer offerings, they're new to us on the outside, but a lot of them have been in use for 5-10 years and have a lot of experience baked into both the implementation, the design that really makes for a really solid offering.
Awesome. Yeah, thank you for that. So next question actually is for you, Stacia. And it's a relatively similar question, which is, we know you shifted over to use GCP for some of your workloads. Can you explain sort of why you chose GCP and what kind of workloads you're using it for?
Sure. There were actually different stages for us moving to Google Cloud with different motivations. So let me cover some of the use cases. Maybe you can correlate to yours. So the first use case, we were running our platform in Amazon, and we had a lot of APIs that users were using UIs, and we wanted to understand what's the usage of the platform, what customers are doing, what's the cost for different customers. So we collected all of this information in one single place, and it was Google BigQuery, where we could store all of this information at very cheap cost, and then have querying mechanism on top of it, so we could build the reports that we can use internally, as well as share with customers. And then there's also a very nice addition. Google have a product called Google Data Studio that allows to visualize. It's kind of BI tool, so it allows to visualize for us the reports, and again share with customers and ourselves, understanding what is actually happening. So this is the first use case. It was long before when we migrated the whole platform. Another use case was we wanted to build product from scratch. And we decided to go with a relatively small team of developers and deliver this product as fast as possible without any DevOps. So for this, we used managed services from Google. We used App Engine with all the caches, with indexes that are there, with data store. And we were able to deliver this product very fast. And one thing around this, very nice thing, when you roll out this kind of products is the cost grows as you grow. So initially, if you don't have usage of that product, you're actually not paying for this much. And when you have the adoption, this is when you start paying, as well as the auto-scaling that is still there. So right now, if you don't have usage at current moment, we are not paying. But when there's spike of requests, this is when we can easily scale up and meet the customer's requirements. And right now, I think the biggest one is actually when we moved our platform from Amazon to Google. And the reason for this, the motivation here was we wanted to meet requirements for our customers who wanted to be in Google and didn't want to be in other cloud provider. So with this, it was one of the motivation. Other motivations that we heard is frequently people who are migrating to Google get better cost efficiency. And the reason for this is because of the network that you have with Google, the pricing model, the flexibility, how you can switch between the instance types. So it was one of the motivation. Another one was we wanted to mix and match the best technologies from different cloud providers, not tying to a specific cloud provider. So if there is a database that can give like replication across regions and very fast response time, we would like to wrap it into our product and give it to our customers. Another example is machine learning. We want to take all of this and again, give it to our customers, no matter if they're residing in one cloud or another. So that's 3 use cases why we're switching to Google Cloud.
Yeah, those are great stories. And obviously, it's been great to be a part of that journey and see those transformations that you've been able to recognize, both from a technology perspective as well as from a business perspective.
Yes.
So actually, Matt, Aaron, I have a similar question for you, which is, we were really, I think I was really lucky to work with you during the kind of assessment process for figuring out where you wanted to run your kind of new workloads. And you have some really interesting requirements. So I was wondering if you could talk a little bit about, what those nuanced requirements are and what the decision-making process was like when you were looking for a cloud provider.
Yeah, well, we have a lot of team in MadHive we've sort of plucked from other very smart startups, and so we built an early impressive team who have experience across all clouds. And when you get the best of the best together, they kind of say, I want to work on Google Cloud Platform. It's a funny story. We actually tried to hire Simon to do that, and then SATA, we found out that SATA, we don't have to pay for SATA. We get SATA for free with Google. It's great. Best of the best. But like things that were super important to us for like rolling out our products were first and foremost like serverless managed everything. And we mean that like to the absolute extreme. Because when you have, these elite engineers, What you don't want them to be doing is sitting there restarting EC2 instance all day. You want to be paying them to do what they're absolutely amazing at, and just like creating stuff all day. And that, like they talk about Google Cloud as cheaper, gigabytes and gigahertz and this and that. Yes, it's true, but like, that's like thousands of dollars. When you talk about like salaries, it's millions of dollars saved, plus opportunities captured. It lets us really outmaneuver lots of companies in the space, and it's gotten us very quickly here on the stage talking about what we do, which is cool. So thanks, Google Cloud.
Of course.
Yeah, as far as and one of the a couple of things that SATA helped us with was in advertising, sometimes the workloads can get like really spiky, like all of North America is waiting for 8 p.m. for the show to start. And they just wait, and then in that 1 second, there's like this tsunami of requests that comes at you. There is no product on any cloud that scales like App Engine Standard. Like you can just put it and forget it, and that is like absolutely critical to us because ads are money. There's literal money. If you drop one request, that's lost money.
Yeah. I remember working with you early on. We, identified an area where I think we saved, what was it, maybe 100 milliseconds of latency, and you were so excited about that because of all the additional things you could do with those additional milliseconds. And so, yeah, I love that story because it really speaks to what you can do when you're working at sort of the scale of what GCP provides.
Yeah, you can do a lot of database lookups, machine learning work. You can do a lot of stuff in 100 milliseconds.
That's right.
Yeah.
So, as long as we're talking about large scale, Josh, I think I have a question for you as well. You kind of hinted at this in your introduction, right? You process just a tremendous amount of data, and you need to get insights from that data. So could you tell us a little bit about what within GCP has helped you overcome the natural hurdles that come from having to achieve goals like yours?
Yeah, scale is always something that we design for and constantly are evolving and work on significantly. I mean, our business is up many orders of magnitude, per every few years, and now that we've part of a bigger family with Citrix, we're optimistic that'll keep moving in the same direction, probably at a faster pace. So I'm gonna have to leave right after the talk to go get some work done. But the main tools with scale, I'll go back to, again, the agility. A couple of things that stand out is kind of the experience of GCP. When you look at the APIs, they're just generally remarkably well done and easy to understand and consistent, and that leads to velocity with how quickly people can write systems that interact with them that take advantage of the capabilities. That is not always a true experience across different providers, where the inconsistency ends up burning time as you figure things out and get them dialed. The services themselves, velocity and reactivity, you can feel, whether it's App Engine's ability to scale or the load balancer's ability to scale or the ability to hot migrate instances. There's just this underlying design ethos that your platform is at least as fast as you want to go, and that's always good because then you're the limiting factor in your design, and you're not banking on infrastructure that is going to put a limit on it that you may not even know about, and it may not even be in the documentation. So that's always a really important aspect, and that in particular is kind of what has pushed some of our use cases beyond even BigQuery out into moving on to running on Google's platform. How they approached Edge, we're all about speed. We run out of about 100 different points on the planet because we do, among other things, global DNS services, and that's where 10 or 20 milliseconds is a lot. You don't want to take that. You don't want to spend that in transit time for somebody to be able to get an answer for you, and being able to take advantage of the breadth of the data centers and the data center growth and the commitment to expansion, and in the architecture of that edge, where they anycast external IPs and have some capabilities to bring your resources for fulfillment closer to where the requests originate. Those are all really, really important features and things that have earned the respect of our team as they explore and develop and grow on those kinds of capabilities. So.
Yeah, and I think it's worth mentioning. You mentioned the acquisition, but prior to that, you were really doing a lot of this with a very small team. I imagine there's a lot of what GCP offers that kind of facilitated that, right?
Yeah. We had 20-some engineers, and we we deliver many billions of mission-critical decisions and collect many tens of billions of data points every day for companies like LinkedIn and Pinterest and Airbnb. We're running as part of the plumbing that delivers all of those sites to you. And again, we do that with 20-some engineers, and a lot of that's about choosing very carefully. I talked about the efficiency of the APIs and the efficiency of the tooling, and taking advantage of the right managed tiers for the right services. You're not always running raw instances. We do some of that for our highly custom stuff, but you're also taking advantage of things like BigQuery for managed, where I don't have to worry about managing a data pool, and I don't have to worry about deciding on my sharding and scaling. I just dump data in and put SQL against it, and out of the chute, with no more investment than that, I get pretty darn good results. And I can actually even then grow from there to get into some more specialized use cases. And it's like Aaron mentioned too, that you want your people spending their time on the most important part of your solution. You don't want them spending their time on the parts that somebody else, frankly, can do better than you. And the implicit part of that I wanted to talk about is you're also, by extension, taking those people who run the managed services as part of your team. If they mess up their service, that results in your service not being of the quality that you want to do. And so, which products you choose and the quality of the product they've built and the quality of the team that runs it, is important. And across a variety of providers and a variety of products, I think we've all seen that isn't always a super high bar. And so, choosing carefully is an important part to maintaining team velocity and scaling, so that 20 people can run something that runs mission-critical services for so many companies around the globe.
Yeah, that's a great perspective. And so, continuing this theme of massive scale, Glenn, I would like to turn to you as well. I think we've had the unique privilege of working together on two distinct projects, right? A massive G Suite project, and then similarly massive GCP implementation. Being that Monash is one of the largest universities in terms of G Suite users, certainly the largest university in Australia in terms of students, can you tell me a little bit about what synergies you found between G Suite and GCP, especially on the scale you're operating on?
So we initially went with G Suite back in 2009. So at that point in time, we were one of the largest organisations, well, definitely the largest university in Australia going with G Suite, but one of the largest in the world. And we rolled that out over a couple of years, and since that time, we've seen a constant growth in the use of G Suite. So right now, we've got about 120,000 active users within G Suite, and we've continued to see a lot of increase in the use of the various apps. And as we have pretty much every active student and staff member using it, it's a very natural progression for a lot of those users who want to do a little bit more to be able to move into using GCP. There is no effort for them to actually begin using GCP. So with other systems, they often have to go and get access given to them, they need to be given to the resources. Whereas because they're all G Suite, or Google users through G Suite, they can then just begin using GCP. And it's been interesting watching over the last couple of years especially, how a lot of our students are beginning to try a lot of different things. They're developing projects on their own in some cases. Our researchers, they can very easily get access to resources that otherwise they'd have to go through all sorts of other mechanisms to get those resources. So just the fact that they're Google users every single day makes it really, really easy to make that transition.
Yeah, that's great. And, things you were able to talk about where you're able to enable your students to do really impressive work. I think it's a great story that is, I think, unique to Monash. So that's very cool to see. So, Stacey, I think back to you. So, yeah, see, I didn't plan this all that well. we got to work together on your migration to GCP. While I'd love to stand up here and say everything went fantastically and we hit no roadblocks, certainly that's not the case, as you find in large-scale migration projects. Could you tell us a little about what hurdles you ran into during your shift to GCP and what you did to overcome them?
So actually, there were not that many problems during the migration. So we had really great support from our Google team and from SATA with a lot of experience doing these kinds of projects. So actually, there are not that many things that we had challenges with. Also, the thing that we were migrating from AWS to GCP, the architecture itself, it was kind of designed multi-cloud. It wasn't relying on any of managed services from Amazon, and that's why it was like just rewriting some of the Terraform scripts and running the same kind of workload, but on Google Cloud. So the whole project, from the beginning, when we were making the design, how it will be working in Google, through the testing, as well as data migration for some of the customers, it took 2 months. After 2 months, we already were having the first customer who was leveraging our platform in Google Cloud. I would say that if at that point we were using Kubernetes, then this whole migration could take much shorter time frame. There were some lessons learned, though, especially on the pricing side. So something that you need to think about. So basically, typically your services would be breaking down into 2 categories. The first one is stateless, another stateful. So for stateless, it's critical to use the auto scaling, and certainly you can go with an alternative for with using App Engine. But we wanted to have more control and have faster migration to Google Cloud. So in this case, think of your scalability. So you need to if you want to have the cost efficiency for the baseline capacity, it's better to go with commit use nodes, and then you will have the discount for those. But for the auto scale part, which is typically 80% of your cluster, go with preemptibles. The benefits of this, you will have the bigger discount, you will have better cost model, but those nodes could be taken at any time. But for auto scale, it should be fine. For the stateful, if you have an ability to switch to managed service, this will be the best. So first of all, the auto scale is there that typically you will not get from the database that you are managing, as well as the cost because of the multi-tenancy that Google already take care of you. If you have to manage your database, then go and buy all the instances as committed use nodes, because typically databases are not scaling down. So these are the main lessons that we learned that were different from Amazon.
Yeah, absolutely. It seems to be a recurring theme where there's this need amongst many of our customers to look at, I mean, as we all see from this conference, there's a lot of stuff that Google's doing, some really, really cool, powerful things that are sort of new to the market. And so this is something we see regularly, is the need to look at all of these offerings and figure out what are the best tools for your use cases. And actually, Aaron, the next question would be for you on that same thread, because you're using a lot of App Engine, you're using a lot of Bigtable. These are things that are somewhat unique to Google. Can you talk a little bit about what makes those advantages for your business versus your competition? Oh,
yeah, that's easy. These are the things that just scale absolutely infinitely. Bigtable was like kind of my first look into like the potential here for Google as a platform for advertising, when we're just sort of getting our feet wet, running some queries, and getting results back as fast as the network card on my machine in the office could go. I knew we were sort of onto something, and since then it's only been more and more and more. You know, that like out of the box, it's phenomenal. When you add on like more layers, so you know that great engineering team has sort of made it do incredible magic. I can't imagine sort of doing advertising at the scale that MadHive does. You know, running a bunch of like sharded like MySQL and Nginx and stuff like that. Like it just wouldn't happen. And so yeah, surprise, Google knows a thing about advertising, and sort of SATA has sort of helped us stay very googly inside of MadHive. And yeah, it's a great resource for us to have.
Yeah, and like you said, you have a small team of really bright people. You don't want to waste their time managing the stuff they don't have to manage.
No, they have enough work to do already.
Right. So actually, Glenn, my next question's for you. You know, Monash University has a lot going on, right? It's a massive university. So can you tell us a little bit about what you're seeing in terms of the ability to better innovate across the campus by leveraging GCP?
Sure. So, as a couple of people have already mentioned, Google App Engine provides a lot of opportunity. And we almost exclusively use that aspect of GCP. And it provides us the opportunity to both cheaply and easily put into place customized solutions to different problems. And there's a couple of examples of the sorts of things that we're seeing. We recently had the campus security group approach us, and they had an issue that they wanted to be able to track the shuttle buses that run around campus. And in the lead up to the exam period, they wanted the students to be able to find when that bus was going to arrive so that they could know where to head for and when to get there to be able to get to their exam. And a previous solution that they had fallen apart. And we had almost no time to develop this in. And so within 5 days, we were able to, with one dev, one engineer, put together a solution. We used IoT devices on those buses, and from there we imported the data. We used Google App Engine, Firebase, and also Google Maps. And we had a solution up from very start of the request coming in to the working solution within 5 days. And that's the sort of thing that is just about impossible to achieve using other methods. So in terms of quick and easy, pulling together different components, that worked really well for us. Now, another problem, and this is a different scale. So the Institute of Railway Technology is a group within our university who deal with a lot of issues on railroads, and they have a lot of monitoring, analytics and those sorts of things. And they work with mining trains that run in the outback of Australia, so it's some of the harshest conditions you can get on the planet. And as one of the interesting things, they put tracking equipment on these trains, and I was talking to Simon about this the other night. If something goes wrong with these devices, it can be up to 2 years before they can get access to be able to replace them. So when you talk about downtime, if something goes wrong, it's rare that you get more than a couple of years downtime. So they've got to be sure that everything works really well. And so these IoT devices are tracking a whole range of different things. So they're tracking things like vibrations, sound, location, all sorts of different things. And the idea is that they want to be able to understand where sections of track actually need maintenance. And so that data is being fed back to Google, where we can do analytics on it. And there's a whole range of different components that we can pull together from GCP to actually do that. So one of the most exciting areas that I'm actually finding with that is in the whole ML space, and things like auto ML vision, other things like that are providing enormous opportunities to actually enhance what we can do in this area.
Yeah, so I think we're hearing a theme here where you're able to do a whole lot more with a whole lot less in terms of human resources, in terms of time to deployment, even in terms of scale in the case of IRT. So that's really interesting. On that same vein, Josh, I know when we started working together, you were dealing with a, well, relatively speaking, much smaller deal of data than you are today. So can you talk a little bit about what, if anything, really had to change in order to accommodate the significant increase in volume that you encounter today?
Yeah, so I mean, we've been on kind of a classic startup path. You know, you start with one, and you're super excited about your first customer that brings you a little bit of traffic, and then you just kind of grow and grow and grow. And now we're part of the Citrix family, and Citrix is all about choice and cloud and optimizing and mobilizing, delivery of data and apps, and we're really excited about playing a significant role in that. And that, our architecture and our product has kind of evolved, several times as we've gotten larger and as we've taken on more vendors. On day one, we operated. I think we might have had a little bit of Amazon, but we did a lot of leased iron and colos and leased infrastructure from CDNs, and there was a lot of interesting early architecture. A lot of the ways that we've evolved that to deal with scale, again, was to continue to leverage the fact that our system is very layered and has a lot of microservices and has a lot of internal decomposition, so that we could move those things forward. The nice side effect of that is we can move entire tiers of our internal operations, in how they operate, what technologies they use, what vendors they use, and we do that all, while running a 24/7, 365, zero downtime operation. We don't get to say, I'm sorry, we're not going to resolve DNS names for the next 2 hours because we need to do some work on the system. Any given second of every single day, we will get hundreds of thousands of requests, sometimes many more. As Aaron was talking about, a lot of our customers deal with news and media and things like that, and so sometimes you will get spikes. We do a lot of work with game delivery. Christmas morning is a remarkable time for us as well, because everybody's opening up their game consoles and downloading updates to all of their games, and you get this incredibly spiky, sometimes very unpredictable. I mean, you can predict it's going to happen on Christmas morning, but you never quite know how large it's going to be or exactly when it'll hit or things like that. So you need to keep, leveraging the layers in your system can be as reactive and adaptive and resilient in everything. And that's been a key as we've evolved. And it's a big reason why we've taken on, the layers that we've taken on, that we've moved into Google Cloud, because they delivered uniquely reactive, uniquely resilient, capabilities that we leverage. And sometimes it really matters in the details. A lot of people talk about auto this or auto that, but when you actually peel the onion a little bit and do some testing, well, it's sort of auto, and it's sort of fast, and it might take a few minutes or a few hours, or you might hit a hard limit on the resources in a data center, and those things are all really important, because at the end of the day, our customers don't care. We either deliver the service or we don't, and the latter is really not an option for us. And so, we choose our vendors wisely, we choose our technologies wisely, and we've been, continuing to evolve that. The one last point is, being part of the Citrix family has been really exciting, because we're, leveraging a lot of our best practices across some of the other cloud offerings and desktop delivery offerings and cloud utilization scenarios. So, we're looking forward to bringing a lot of that same kind of mentality and approach to the broader offerings and the good work that they're already doing in a lot of those spaces. So.
Yeah, it's an awesome insight that you're able to provide, because I think your team generally has stayed pretty similar in size, and echoing what the other panelists have said, you've really been able to do so much more by leveraging various components of what cloud has to offer. So I think that's a great story. So Aaron, I have another one for you, just because this is one of my favorite things to talk about. We joke all the time, right, that you deal with blockchain and you deal with cloud computing, and are there any other buzzwords that I'm missing?
AI.
So these sound like I'm just trying to sell a white paper or something by saying blockchain and cloud computing in the same sentence, but it's what you're really doing. Can you tell us a little bit about what those things do together and how you're able to, achieve what you do using those technologies?
Yeah, this is a really good question that we get a lot, because it's not a secret that we're very big users of Google Cloud, and we're also very active in the blockchain community. Our researchers dedicate tons of time to it. We have a lot of contributions that we're super proud of, but people who are familiar with blockchain are like, hey, this is literally cloud competitor. It's cloud is all about centralization and, authority, and blockchain's all about decentralization and not having to trust, knowing things are true through cryptography. They actually work really, really well together. So if you recall, like what we talked about in the beginning about like one of the big problems in advertising is auditing. You know, like ads are literally money, and they're even, the auditing standards should even be higher, because this is a case where, unlike in like, you know, banking and Wall Street, where, you know, there are shares and dollars and things that go around, ads get like made. You just create money. And if you have opportunity to create money and you have like a lot of opacity in the supply chain, there's going to be problems. So one of the things that we do is sort of, we're going to walk back through this whole process, is you can use cryptography. Cryptography is more than just like, you know, like encrypting messages. Cryptography is about also like, you know, validating the integrity of data without necessarily revealing why. So for example, if we have like REST endpoints, you know, most REST endpoints are like, you know, like there's a web request, it does a database query, and then it gives back a result. We can do things like, with the addition of cryptography on this, we can make it that the data, even though you didn't reveal what happened underneath, we can reveal the provenance and sort of the supply chain of that data. And then that's super useful, because now it's just as easy as a REST endpoint, but now, you know, I get to know, oh, okay, this data has some validity. It went through partners and it went through transforms, and I don't have to know exactly what those transforms were to know that it's correct. Because if even one thing changed, everything just breaks. Cryptography is neat like that. The other thing we can do is, you want sort of some universal base. So, you know, we have this string almost that carries through all the data as it goes through the supply chain. And that's where the blockchain part really comes in. It becomes really useful, because that is our universal truth, where everyone in the industry is working really, really hard to maintain this, just some base level of truth. And the math gets complicated, but just, you know, say like we're all agreeing that number is 5. Number is 5 right now, and that's where we all anchor our strings. And now across the entire ecosystem, we're doing, you know, REST calls, database lookups, queries, transforms behind people's servers in large data centers. But we know with absolute cryptographic certainty that the answers are correct. And also, when we're done sharing data, that we can revoke that. And immediately it goes all the way through the supply chain. Not by trust, not by contracts, not even by privacy laws like the new European regulation for privacy, GDPR, literally by the force of physics, cryptography. And that's a really, really exciting solution to be able to offer in our industry. And we've been working with the blockchain standards body for advertising called AdLedger. We're also one of the founders, along with IBM and Tegna and a bunch of large companies. And so we're happy to make that contribution. But I think the most exciting thing about that sort of combination is, like you talked about cloud and blockchain, you know, I've been attending a lot of the sessions here about machine learning. And, you know, like Google and cloud is all about AI and machine learning. Like that is the killer use case. But machine learning and AI are only as good as the data that you can source. And while Google has done an amazing job of collecting up like tons and tons of data in one place, and it shows in their products, there is a limit to that, because we can't all sort of share our like business data or as consumers or private data. And we probably don't even want that to go into these big machine learning things. And so that is like a hard stop for the evolution of AI. It shouldn't have to be like that. We can use the same privacy techniques that we discussed for consumers and across these, you know, data supply chains, and you can put that into machine learning, and that's like the killer app. Like AI plus cryptography is like, that's like everything. That's like literally the new internet. I think that's what we're going to be talking about here in the next decade.
Yeah, no, I love that story, because I think that is the common misconception, is that these are somehow competing technologies. But you really do paint the picture as to how these things can actually be very complementary. And I love squashing that bad stereotype. So unfortunately, I think we're just about out of time here. So I just wanted to thank all of you for being here with us. Thank you all for attending. And we will all be somewhere around here afterwards if anyone has any questions for us. So thank you, everyone.